Hello and welcome to my session. My name is Papakonstaninou and I'm the director of the Rice University School Mathematics Project. I'll be talking with you today about challenges and tips to getting students in the math fast track. Please remember to download my slides from resource space on this website. Following my presentation, I'll be responding to your questions in the chat space for the live Q&A. Now, let's get started. I am a lifelong math educator. I began my teaching career in 1971 as a high school teacher and taught every math class from fundamentals of math through BC Calculus, IB Mathematics, and Independent Studies. In my current position as director of the Rice University School Math Project, I design and implement district-wide programs that impact the teaching and learning of mathematics and document their impact on students, teachers, schools, and school districts. I regularly teach courses for math teachers that demonstrate active learning of important mathematics and also teach courses for high school students. I make every effort to open doors for others and to help them achieve success. What I'd like you to do now is walk down the hall of my high school. Imagine that you're going to peek into an advanced placement calculus class in this typical urban senior high school. It's ethnically balanced, of course. Who are the students in this class? Well, they're white and Asian males with a sprinkling of white and Asian females. Now let's go down the hall and imagine you're observing the remedial math class at the same school. Who are the students in this class? Black and Hispanic students. Questions I've thought about my entire career. Why is there such a disparity in the two student populations in calculus and remedial math? Why are math classes the most segregated places in American society? I want you to look at some facts. In 2021, 43% of the students in public schools were Black or Hispanic, compared to only 13% at the end of World War II. In the Houston Independent School District, where Rice University resides, in 2020-2021, of the nearly 200,000 students, 62% were Hispanic, 22% were Black, 9.7% were Anglo, and then the lower groups, Asian and American Indians, only approximately 5%, and two or more races, 1.6%. The study of math in the United States has been dominated by white males. More facts. The U.S. Hispanics and males, Hispanic or Black males and female students earn only 14.8% of the bachelor's degrees in math and statistics, and fewer than 4.3% of the PhD degrees. White males receive 33% of the PhDs in math and statistics awarded to U.S. citizens. In 2019, foreign-born workers accounted for 19% of the STEM workforce, with 45% foreign-born workers in the U.S. with PhD degrees. The number of temporary visas for professional workers has generally trended upward, and it more than doubled from 97 to 2019, with a flatness during COVID. The numbers show that the U.S. may soon face a shortage of talent in critical areas of science and technology. More H-1B visas are issued than any other type of temporary professional worker visa. Although H-1B employees may work in various fields, the majority are hired in STEM occupations, with about 2/3 of them in computer-related fields. The United States is just not educating enough of its own students to satisfy our technology-hungry workforce. If these trends continue, we're going to have a serious undersupply of qualified technical talent. And with the increase in prosperity in America, children of the higher SES strata are pursuing other careers where they don't have to work as hard as in the STEM careers. There's a low interest in scientific careers among the fastest growing demographic sector of the U.S. population are Hispanic Americans. Here's some other facts. American whites produce an average of 54% of the bachelor's degrees in STEM fields. Blacks only produce 9.2%. Hispanics, 15%. Asian and Pacific Islander Americans produce 16.4%, and it gets lower and lower. Let's take a look at U.S. pre-college math performance. On the NAEP as of 2019, and these data are from 2022, 60% of the 12th graders performed at or above the NAEP basic level. That's down 2% compared to 2015. 40% of 12th graders performed below the NAEP basic level. That's the lowest level, up 2 percentage points compared to 2015. And it's dismal across the ethnic groups and the SES groups. 40% of all students scored below basic, 54% of the Hispanic students, 66% of Black, and 57% of low income, whereas 28% of students with college-educated parents. Math moves our society forward. At the White House National Science and Technology Conference meeting in 2000, it was stated that it's a fundamental responsibility of a modern nation to develop the talent of all its citizens. We, however, are coming closer to developing a permanent underclass who will never benefit from the strong economics and leadership potential of science and technology. We must get more of our students, especially our underrepresented students in STEM, into the math pipeline. And we must sustain these students, especially our underrepresented students in STEM, as they move through the math pipeline. In order to sustain them, they must have the prerequisite knowledge and skills to remain in the pipeline, and the instruction that makes studying math relevant and meaningful. The math pipeline has a huge dropout rate. From ninth grade through the PhD, the half-life is 1 year. We lose half of our students each year, beginning from Algebra 1 through the PhD. Beginning with 3.2 million students entering high school, we lose 50% each year until a very few hundred attain the PhD. There's a definite decline in the annual productivity of mathematics education in the U.S. 52% of those who initially declare as math majors end up majoring in something else. They just don't stay in math. Despite all this time and effort to teach kids calculus, very few students even consider majoring in math. In fact, only about 1%, over 2 million annual college graduates, major in math. Most students take calculus in high school and do so to have a great transcript to get into college, and then they turn around, 80% of them, and take it again in college. These are dismal statistics. Losses from the math pipeline come disproportionately from females, blacks, Hispanics, and Native Americans, but at different stages. Blacks drop out early, at twice the national average. Hispanic dropout rates are not as high as those of blacks, but at most, they're much worse than the national average, which itself is just not acceptable. Women persist through undergraduate degree, but drop out during graduate school. Our fastest growing population, the underrepresented groups, currently produce fewer than 2% of our scientists, mathematicians, or engineers, and future indicators suggest little change in this pattern. For example, virtually none of the black college freshmen who scored the highest on the math SAT test indicated an interest in majoring in math. The sobering reality is the largest growing population in America, our Hispanics and our blacks, are those who are most likely to drop out of the math pipeline. Why? University professor Richard Tapia, let me tell you a little bit about Richard. He's a dear friend. He's a mathematician and university professor in the Department of Computational and Applied Math and Operations Research here at Rice. He is internationally known for his research on computational and mathematical sciences. His specialty is optimization, and is a national leader in education and outreach programs. He received the 1997 Lifetime Mentor Award from AAAS. In 2011, President Obama awarded Richard the National Medal of Science. He often says no first world nation can maintain the health of its economy or society when such a large part of its population remains outside of all scientific and technological activity. The world is changing. Math is everywhere, in the workplace, in our daily lives, and those people who see it and understand it benefit greatly. The equity principle of the National Council of Teachers of Mathematics is one of 6 principles, with equity cited first, followed by curriculum, teaching, learning, assessment, and technology. These describe features of high-quality mathematics education, and the principle states that excellence in math education requires equity, high expectations, and strong support for all students. To achieve this goal, We must raise expectations for students studying, learning, and developing methods of supporting and helping kids learn mathematics and provide students and teachers with all the resources that they need. Course taking is the most powerful factor under a school's control that affects student achievement. And I saw this every day. We must demand the highest level of academic achievement of all students and not sort kids by ethnic surname or color. Today, the goal must be for all students to take mathematics courses each year through 12th grade. Using a longitudinal sample of approximately 5,000 young people pursuing the bachelor's degree, and this was 1988 through 2000, trustees studied how credits in intensive math courses affected students' completion rates of their bachelor's degree. Finishing one unit in any of 4 intensive math courses, Algebra 2, Trigonometry, Pre-Cal, or Calculus, more than double the likelihood that these students would later complete the bachelor's degree. Geometry wasn't included because its intensity is variable across the country. The goal of all educators should be to ensure that every math course is of the highest quality. Too many underserved students in STEM fail to receive academic counseling, encouraging them to take AP courses. Black or Hispanic students surveyed for a recent joint report from the Education Trust and Equal Opportunity Schools said they had a passion for studying STEM courses, yet only 3% were enrolled in AP STEM classes. Most minority students do not receive academic counseling, encouraging them to take advanced STEM courses and advanced math courses. Underserved populations in STEM have traditional values that stress gender differentiated roles, and therefore girls get a double disadvantage, whether they're Black or Hispanic. Math teachers and counselors must communicate the importance of studying mathematics to prepare for future careers and to increase the possibility of earnings and to function in society, and not just for white males or Asian males or a sprinkling of white and Asian females. This should be for all students, and they have to push for equity. NCTM has a position on closing the achievement gap. In order to close the gap, all students need the opportunity to learn challenging math from well-qualified teachers who will make connections to their backgrounds, their needs, their cultures, all learners. And this was adopted in 2005. Teachers' expectations and belief systems affect students' math achievement. Every student should be taught by teachers in schools where expectations are high, regardless of the community where the school is located. And this is not the case in America. Teachers should be mathematically competent and pedagogically proficient. Convincing evidence suggests that teachers play a significant role in closing the achievement gap. Unfortunately, students who have the greatest needs often have the least qualified teachers. So I have suggestions over my 50-year plus years in the classroom and in education. Teachers need to interact with all students and not with just white males. Eliminate the bias, if possible, in the way you interact with students. Encourage all of them. Discuss math anxiety with your students and share your personal beliefs. All of us get anxious at times, even those of us who were successful as math majors. There's still topics that you panic a little bit about when you teach, and you need to tell that to kids. Everything isn't nice and tidy. Encourage your underserved student populations to seek interests that involve math. Math clubs, math tournaments, math buddies, and don't accept failure from your underserved student populations in STEM. Don't accept it from any of them. And now we have a large language minority. We have to be careful with our language. Review terms, words, phrases, topics from previous lessons, have the kids speak them, give opportunities for kids to talk math, stress reading and writing skills in the math lesson, and above all, provide a nurturing environment for all students. So how do you get kids into the math fast track? Well, ideally, today they begin in 8th grade with the study of Algebra 1, followed by geometry. This is in Texas. Algebra 2, pre-cal, and then AP calculus, and there's A, B, or BC. This is not only what they should be studying. We have AP statistics, AP computer science. They should be trying to take those courses too with pre-cal or calculus if desired. The more math, the more computer science, the more statistics, the more calculus, the more prepared the student will be for college. And I'm not saying they all have to take these courses, but these are courses that will serve them well in college in any major. Now, how do you get kids in the math fast track? Well, ways that we've done it: curriculum compacting, where you skip materials that the students have already learned. Grade telescoping, where you take a program that maybe took several years and compact it into fewer years. Then there's summer school with qualified teachers and not just paying the money to get the credit. Concurrent enrollment in non-sequential math courses and credit by examination. So let's look at these other pathways. Now, not all kids begin Algebra 1 in calculus in high school. Now, does that prevent them from getting into calculus in 12th grade? No. If they take it in 9th grade, then they can double up with geometry and Algebra 2 in 10th grade, pre-cal in 11th, and then AP calculus in 12th grade. And this works. I've tried it with years and years of students, and they make it, and then they're successful their senior year. Another pathway is, again, what if kids take algebra in 9th grade? Well, they can go to summer school and take geometry with a carefully selected teacher who knows the content that they will need in subsequent courses. They do that between 9th and 10th grade. And then Algebra 2 in 10th grade, and they're back on track for calculus in 12th grade. For the late bloomers, and yes, we have late bloomers. We have kids who take Algebra 1, geometry, and Algebra 2, and then they become 11th graders and they say, but I want to take calculus or AP statistics or computer science. Well, pre-cal can be taken in summer school. Now we have strong dual credit courses. Again, the dual credit teacher must know the content that kids must have to be successful in calculus. This is better for AB students, but BC students can also go through this pipeline. It's harder for them because they haven't been in the advanced classes forever. Advice to schools, please implement high-quality math courses taught by knowledgeable teachers throughout the math pipeline. All students, especially our underrepresented students in STEM, must be aware of these courses and not be left out. The push to get AP Calculus on the transcript is causing a concern in some circles and deserves a word of caution. AP Calculus is considered by some to be the pinnacle course in high schools, so students think that calculus is really the important course and not to worry about the other courses, that everything else is just a prelude to preparing them for calculus. This de-emphasis on other courses to rush into calculus has extreme negative consequences. On the TIMS, our calculus students did poorly, not on the calculus, but on the pre-cal and the geometry sections. Students are being rushed through geometry, algebra, trigonometry to get to calculus. Super acceleration is a problem too, but that's the subject of another presentation. The math we teach must meet social and economic demands of the world, but we must take steps to ensure that everyone has an opportunity to participate. Thank you very much. If there are any questions, I'm happy to try to answer them.
We've got a message from Carolyn White. She asks, is it possible that the outline of taking courses for Algebra 1 would be similar in other states other than Texas?
Well, I don't feel I can speak for other states. I've written curricula for decades and decades, and the Algebra 1 is a flow that makes sense to me because a teacher cannot teach something that doesn't make sense to them and they can't justify. So the flow that we've established in the schools and districts where I've had conversations with teachers works for us, but then I don't know about other states, so I don't want to generalize what I do. Thank you. Thank you, Carolyn, for your question. Right now in the country, there is a rush to get kids to take courses just to get them on the transcript, and we are doing harm to students by rushing them through math. Getting them in the fast track is important, but we must do it responsibly. We cannot skip topics because the foundation is damaged for the kids, and it puts a burden on teachers who receive kids when a whole year or two of math has been skipped because it's a status thing for some people. Some kids need to accelerate, but others need to have time to really learn the content and to be able to retain it and use it and find some joy in learning. And rushing kids is something that is doing so much damage. And if anyone wants to follow up on that, I'm happy to talk about that too. I've been teaching since 1971, and the problems never go away. They get worse. This generation of problems is much worse than the problems that we faced as educators for getting our best and brightest into STEM fields. And it's heartbreaking to see the joy of learning math destroyed by people who are seeking status. And a lot of that is just doing so much harm. We need a Hippocratic oath for educators and educators and leaders. And our organization has developed those, and they're published in NCSM's inspirations. We've got to do better. And I'll just leave it at that.